Hello guys, welcome to application of derivatives as rate measure part 2. We'll be doing the rest of the two questions as I had said in the previous video. So for the first question, let's see. This is a very important question and is most likely to be asked in the board examination for SLC. So here it says water flows into an inverted conical tank. So inverted conical tank at the rate of 42 centimeter cube per second. So he's given us the rate of change of volume is 42 centimeter cube per second. How fast, when the depth of the water is 8 centimeter, how fast is the level rising? So it has asked us dH by dt equals to what? So let's just say that this is the height, this whole thing is the height. So it's asking us the rate of change of the height with when it is at 8 centimeter. Assume that the height of the tank is 12 centimeter and the radius at the top is 6 centimeter. So this right here, this radius is equals to, well, 6 centimeter. So it is giving us when that h prime, let's just say this part, h prime is equals to 8 centimeter. So we have r prime here. Now what you will need to do is, well, geometry now. Here let's say you label this as A, B, not here, A, B, C, D, E. So here, well, we can clearly see that triangle ADE is similar to triangle ABC. Of course, you can prove this by, well, angle, side, I think. No. Well, you can prove it. Oh, shit. Well, you can prove it by angle, angle. So this gives us similarity. So here, this is, well, we can use the similar triangle properties, which is the ratio of the sides is equal to the ratio of another side. So here let's take the height ratio AD by AB, which will be equals to DE, this is E, DE by BC, or wait, I'll write a given height 12 centimeter, radius equals to 6 centimeter. So AD, which is the height prime by height, is equals to radius prime by radius. Now here let's find the relation of radius prime to height. So we have radius prime is equals to height prime, which is 8, height, which is 12, and radius, which goes up, into 6. Well, actually we need to find the relation between radius prime and height, so let's just not write the value for now. So this is equals to 1 by 2 of h prime. So now we know that the volume of the cone is 1 by 3 pi r square h, but in this case it's r prime and h prime. So here dv by dt is equals to 1 by 3 pi r square into 2, pi is constant, and the radius prime we can write is, well, let's not do the derivatives right now. R prime we can write it as 1 by 2 h prime, and square that we get 1 by 4 h prime square into h prime. So this will be v equals to pi by 12 h prime cube. So now we can differentiate both sides with respect to time. We get pi by 12 into 3 into 3h prime square dh prime by dt. So we have to find this. Now here we can just put in the values. We'll get 42 equals to, this is pi by 4 into 3 into h prime is 8 square and dh prime by dt. So into dh prime by dt. So overall, we'll just get dh prime dt equals to, well, let's just do directly write the answer, right? Because all of this are just some value, and this will all go down here divided by 42, and the answer will be 21 by 8 pi centimeter per second. That is the required answer. Now for the next question. So in rate measure, basically you need more geometric knowledge than you will need for calculus knowledge or knowledge about derivatives. Because for the next question, we'll also be looking at some analytical geometry. So a point is moving along the curve y equals to 2x cubed minus 3x squared. So let's just make that curve in such a way that its x coordinate is increasing at the rate of 2 centimeter per second. So here it is given dx by dt, let's just say x, y, dx by dt is equals to 2 centimeter per second, and here y is equals to 2x cubed minus 3x squared. Find the rate at which the distance of the point from the origin is increasing when the point is 2, 4. So it is given point 2, 4, essentially x equals to 2 and y equals to 4. Let's just say it's right here, 2, 4. So we have to find the distance from the origin. So here, let's draw this. This is y, this is x. So we will have to find, according to the question, we'll have to find ds by dt. So here, let's just differentiate both sides to find dy by dt, which is 6x squared minus 6x whole dx by dt. So here, this is 6 into 2 square minus, well, let's just take the 6 common to make the math easier. 6x square minus x, which is, well, 2 square minus 2 into 2. So 6 into 2 into 2, 6 into 4, which is 36. Let's just write centimeter per second, right? And then for s, this will be equals to, well, let's use the Pythagoras theorem first. X squared plus y squared equals to s squared. So s is equals to root x squared plus y squared, which will have root 2 squared plus 4 squared, giving us 20. Now here, from here we can differentiate both sides. We'll get 2x dx by dt plus 2y dy by dt is equals to 2s ds by dt. We can just cancel all the 2's and let's just put in the values. 2 into 2 plus y is 4 into 36 equals to root 20 ds by dt. So here 4, well, I'll just write the answer directly. Here ds by dt will be equals to 10 root 5 centimeter per second. Thank you.